We're looking to find y prime where our y value is equal to x to the sine x. And you can already see what the problem is here, right? We've got an x here as our base, but also we've got an x stuck inside of our exponent. So let's see how we piece this and tear this apart so we can take a derivative, because we cannot take the derivative as it stands. First thing that we're going to do is we're going to take the natural log of both sides. Notice if we do this with both sides of our equation at the same time, we're going to be just fine because it's not going to change the equality at all. What it will do is it will allow us to take sine of x and bring it down into the front of our natural log. Because when you take natural log of any value to an exponent, you can always rewrite that as b times the natural log of a. So that's a nice little tool to have in our tool belt. All right, so our next step, we have natural log of y is equal to sine of x natural log of x. And these two are multiplied together. We'll just put parentheses there so that it looks pretty nice right there. Next thing that we're going to do is we are going to take the derivative with respect to x of both sides. Now, the derivative of natural log of y, so natural log of y, take the derivative as we normally would. Natural log of something is 1 over something. And then we're going to multiply that by derivative of our inside, which is a dy dx, which is actually our y prime right there. So we've got that set, which is great. On the other side of the equation, we're going to use our product rule. So we're going to leave our first bit alone, sine of x, derivative of our second bit, derivative of natural log of x is 1 over x. And then we're going to take plus derivative of our first part, which is cosine of x, and then leave the second part alone. So now we have natural log of x. All right, this looks a lot better. Next thing what we're going to do is we're going to put big brackets around this, and we're going to take this 1 over y prime, we're going to multiply by both sides by y, so we can bring y over to the right-hand side of our equation there. So this is going to give us dy dx is equal to y times, and I'm going to rewrite sine of x times 1 over x as just sine of x divided by x plus our cosine of x natural log of x. Now we could leave it here, but let's do one last step. You'll notice here we have a y stuck in here, and although that's okay, we know that our original equation for y was that is equal to x sine of x. And it's nice to get our y prime, our derivative, all in terms of x's. So our y prime is dy dx, and we're going to substitute that in there. Oops, sine of x, and then we're going to throw the rest of our equation in here, plus cosine of x, natural log of x. There we go. And here is our solution for our y prime that we were looking for. Thank you for listening.